My name is Ledvina.
And I'm Alexa Bullmore.
We're talking about applications of organic chemistry. As we have struggled and crawled through 2 semesters of organic chemistry, it often feels like a topic far removed from our everyday life, only calling on our knowledge of molecular interactions and reaction mechanisms inside the classroom. It is often overlooked and neglected that many of the necessities in our everyday life would not be available if not for the past chemist discoveries and innovations. The reality of the role played by organic chemistry in modern existence is best summed up by the famous advertising slogan of the 1930s, "Better living through chemistry."
First, let's take a look at a world without chemistry. We would have to take away rubber, which would make driving slightly more challenging, as well as gasoline, rendering everyone relatively immobile based on the needs of our day-to-day lives. Not only would gasoline be out of the picture, but also every one of the vast array of petrochemicals used to power civilization. Toothbrushes, vitamins, aspirins, and all other types of drugs, perfumes, and toiletries would all have to go. Not to mention plastics. Take a second to think about how many times per day we use or encounter plastics. The majority of a car is made of plastic. PVC, plumbing, computer housings are just a few of the numerous polymers we encounter daily.
Polymers are long, stringy molecules made of smaller molecules called monomers. They appear in nature, but thanks to Corthers, a tragic figure who committed suicide a year before nylon made its public debut, as well as other scientists and inventors, synthetic polymers are a fundamental part of daily life. The structure of even the simplest polymer, polyethylene, is far too complicated to discuss in ordinary language, but must be represented by chemical symbolism. Indeed, polymers are a subject unto themselves, but it is worth noting here just how many products used today involve polymers in some form or another.
Polyethylene, for instance, is the plastic used in garbage bags, electrical insulation, bottles, and a host of other applications. A variation of polyethylene is Teflon, used not only in nonstick cookware but also in a number of other devices, such as bearings for low temperature use. Polymers of various kinds are found in siding for houses, tire tread, toys, carpets, and fabrics, and a variety of other products far too lengthy to enumerate.
This relates directly to organic chemistry because of the carbon chain nature and the reactions needed to synthesize and add chains. The most common type of addition, polymerization, is free radical polymerization. A free radical is simply a molecule with an unpaired electron. The tendency for this free radical to gain an additional electron in order to form a pair makes it highly reactive, so that it breaks the bond on another molecule by stealing an electron, leaving that molecule with an unpaired electron, which is another free radical. Free radicals are often created by the division of a molecule, known as an initiator, into 2 fragments along a single bond.
Organic chemistry is also essential in biological and medical fields. All living organisms are composed of abundances of organic substances. Evolution of life has been postulated to have been developed from one single organic compound called a nucleotide. Nucleotides polymerize or join together to form the building blocks of all life, deoxyribonucleic acid, or DNA. Pertaining to the medical field, pharmaceuticals are also composed mainly of organic compounds. What doctor would be efficient if he or she was not familiar with the structure and function of drugs that they were administering? Organic chemistry of pharmaceuticals must be understood to properly prescribe a drug to a patient. Another real-world application of organic chemistry is found in the functional group known as esters. Esters are derived from carboxylic acids where the hydrogen group is replaced by a hydrocarbon group of some kind. Esters encompass a large form of organic compounds with applications in biology, chemistry, industry, and medicine. An important ester is known as acetylcholine, and it is an ester of acetic acid and choline. It is an organic molecule that acts as a neurotransmitter in many organisms. It was the first neurotransmitter to be discovered, and it was identified in 1915 by Henry Hallett Dale for its actions on heart tissue. It is a neurotransmitter in the autonomic nervous system, and it acts upon the peripheral and central nervous systems. It is the only neurotransmitter used in the motor division of the somatic nervous system, and it is the principal neurotransmitter in all autonomic ganglia. It has an inhibitory effect in cardiac tissue, which makes it lower the heart rate, and it acts as an excitatory neurotransmitter at the neuromuscular junctions in skeletal muscle. So those are just a few of the many examples of organic chemistry that we see in everyday life.